In this video, we're going to look at section 0.2, which is on two-way frequency tables. The learning targets for this lesson are going to be to calculate probability with two-way frequency tables and use data to complete a two-way frequency table and also calculate probability with that. A two-way frequency table, the definition is it's a way to display multiple categories from the same sample size or same data. This is similar to what you learned back in Math 1 when you did probability. In this first example, we're looking at a set of data and breaking it up into different categories. So one is we're breaking it up between cat and dog, and we're also breaking it up into people who live in an apartment versus a house. So you're going to see like these middle four boxes are how we're separating, how we kind of aggregate or separate that data out. And then the bottom row and the last column are going to be the totals for each of those categories. One thing you always want to make sure that you recognize in a two-way frequency table are how many people or what's the sample size that's being represented, and you can see that's right here in the corner. Our n, or our sample size, is going to be 1,547. So when we go through this, we're still just going to be calculating probability, but keeping in mind, in this case, the number of people that are represented in this table. The first one is talking about the probability of someone owning a cat. So if you look at our column for cat, you could see 799 people own a cat. And of those 799 people, it's going to be out of 1,547. And so our probability of someone owning a cat would be 0.516 or 51.6%. For probability of a dog, it'd be the same thing. So in our dog column, we're at 748. So it'd be 748 over 1547. And when we divide that, we'll get 0.484. Okay, our next example is going to be looking at conditional probability. So the probability they own a dog if they live in a house. So that second term in conditional, if you're looking at a two-way frequency table, that's usually what you're using as the total amount, right? Because of the people who have a house, of the people who have a house, that's 910 people, so that's going to go on the bottom. And of those 910, 586 own a dog. And so when we divide that out, we're going to get that to be 0.644. Okay. For part D, it's asking for the union. So the union, keep in mind, we want to be careful. We're looking at the probability of a house or a dog, but we don't want to count anything more than once. So it's really, we're doing here the probability that someone lives in a house. We're going to add the probability that they also own a dog or own a dog. But we're usually going to subtract off the intersection only because we don't want to count two groups of people twice. So on our table, we're still taking it out of that total of 1,547. And so the probability that someone lives in a house, well, the total amount of people in a house is 910. Because that includes the 324 and the 586. The probability that, or the number of people who own a dog is going to be 748 because it's 162 and 586. But then we want to make sure we counted this 586 twice, so we gotta subtract it off. So we have to subtract off that intersection. So when we go ahead and calculate that out, that's going to end up being 1,072 over 1547, which ends up being 0.693. And then finally, the last one is asking for what's the probability, and this is the intersection, so they own a cat and have an apartment, so that's like the and. So a cat and an apartment is 475. So I'm going to do 475 over 1547. And so that probability would be 0.307. In the second example, we're going to be completing the two-way frequency table and then calculating the probabilities. So for this one, again, just remember you have your row of totals and a column of total. And we're just going to either do addition or subtraction. So for example, the adults who like fiction and children who like fiction should add up to 85. So if I subtract, I would get this to be 35. The adults who like fiction and nonfiction is going to add up to the total of adults, which is 45. The number of adults and children will be the total number of people. That's 105. And then from there, we can maybe do some subtraction. So if I know the total is 105, if 85 shows fiction, the remaining, if I subtract it, shows nonfiction, which was 20. And then I can get this to be 10. So when we go ahead and calculate the probabilities, very similar to what we already did. So number of children, this is 105, or the total is 105, and the number of children was 60. So that would give us this probability of 0.571. The probability of nonfiction, given that they're an adult, adults would be 45. So the second term is usually what you're going to take it out of. Of those adults, 10 chose nonfiction. So 10 over 45 is 0.222. The probability of children or that they chose their children or they chose fiction. This one's a little making sure you're not double counting. So 85 people chose fiction. 60 of them are children, but we want to make sure that we don't count this 50, that intersection, twice. So we're going to go ahead and add and do some addition and subtraction. Okay, so we know it's going to be out of 105. And then we're going to do 85 plus 60 minus 50 and get 95. And get our percent. And then the last two, same thing, so they're both going to be out of 105 because that's our total amount. The probability of fiction, and they chose fiction and they're an adult. So that would be, erase this a little bit here. So that would be fiction and adult would be 35 over 105. And then the last one is probability that they're not an adult, right? So that means we're not taking, we're basically not including any of this right here. So in this table, if they're not an adult, they're a child. So that would be 60. And so it's 60 out of 105. And it's actually the same as the probability of a child, which we did already for A. If you have any questions, you could reach out for help during T-Bowl time. Go to the